Can't hear you.
Hello, everyone.
Yep. Better.
Good morning, especially for the participant from the Netherlands and Europe. And good afternoon, especially for the participant from Indonesia and mostly Asia. Welcome to the fourth session of INTPF, Indonesia, the Netherlands Technology Partnership Forum 2021 on immersion cooling technology towards greener and more energy efficient data center. Thank you for joining. INTPF is organized by IA-ITB NL, or Bandung Institute of Technology Alumni, the Netherlands chapter, together with the Embassy of Indonesia for Netherlands, the Hague, and supported by Energy Academy Indonesia, ECADIN. For this year, 2021, our main theme is on sustainable energy. And for today, we will have a topic of energy efficiency for cooling technology in data center. In particular, we would like to discuss about the policy, the demand, and the challenge to implement one of energy efficiency cooling technology in data center, liquid immersion cooling. So, as the moderator for today, let me to introduce myself. My name is Muhammad Faris Noval Austen. I'm a data center professional in Indonesia. And as a disclaimer, I'm also one of the alumni of Bandung Institute of Technology. So every comment and question from me will not represent the view of my employer. Okay, to start my task as moderator, let me explain the format of today's webinar. In total, we will have 2 hours of webinar. There will be 1 keynote speech and 3 presentations from our speakers for about 15 to 20 minutes. Then after that, we will have panel discussion until the end of webinar. Participants may also to join the discussion by submitting the question via YouTube chat or Zoom chat. And the participant who would like to get the certification of attendance, link is shared in the chat box and email. It's an honor for me to be present here together with our all of distinguished speakers. We have here Bapak Haris Yahya on behalf of Pak Dadan as the Director of Geothermal, Directorate General of New Renewable Energy and Energy Conservation, Ministry of Energy and Mineral Resources. Hello, Pak Haris.
Hello.
Yeah.
Mas Faris. Oh, Haris and Faris.
Yeah, Faris.
Okay.
Pak. And also we have Marco Ciovi as Director of Operation at PT DCI Indonesia. Hello, Marco.
Hi. Hello, everybody.
And also we have Michael Borisius as Business Development Manager at Asperitas. Hello,
hi, everyone.
Michael.
Hi, Faris. Hi, everyone.
And also we have Patrick Chan as Vice President of South Asia at Uptime Institute. Hello, Patrick.
Hello, everybody. Greetings. Hope you are all okay, safe, staying safe. Glad to be part of this event. Thank you.
Okay, everyone. Thank you. Thank you for collaborating with us in this webinar today. And for the first, we will have Bapak Haris Yahya from Ministry of Energy and Mineral Resources to present about Indonesia Energy Conservation and Efficiency Program. To Pak Haris, you may start the presentation.
Yeah, thank you, Mr. Faris. Good morning, Netherlands, and good afternoon, Jakarta. So my name is Haris. I'm from Directorate General of New and Renewable Energy and Energy Conservation, as Director of Geothermal. So allow me as a representative of Pak Dirjen, Mr. Dadan, because today he also has another activity, so he allowed me to represent him bring to convey the welcome speech today. So first of all, I would like to convey my highest appreciation to the IA-ITB NL, and then also together with the Indonesia Embassy for Netherlands, and also supported by Energy Academic Indonesia. So very good time for us to be here to share about the energy efficiency development in Indonesia. So before start to the first slide, I would like to share some additional information that now Indonesia start to develop more ambitious of our target in a green energy. So now we are in progress to implement we call it net zero emission. I think you are also already known this kind of activity. So we are in preparation also to achieve the net zero emission target by implementing all of activity in the demand and the supply by green energy base. I think we can start the first slide. Yeah, this slide mentioned that our commitment. Indonesia already has a commitment to reduce our emission by 29% in 2030. And that means we have to reduce about more than 800 million tons CO2 emission in 2030. And we are also targeted about 1 billion CO2 emission reduction by inviting the assistance from other countries. And more specific in energy sector, we are targeted to achieve more than 314 million ton CO2 emission in 2030. And more specific, what kind of renewable energy and energy efficiency that we try to do to achieve the target is we try to develop more renewable energy, because from 314 million tons CO2 emission, our target 170 million ton from renewable energy. I would like to maybe in this case we don't specify for the renewable energy, but in energy efficiency. But I would like to add some information related to renewable energy. Now we are develop more than 10,000 megawatt of renewable energy in implementation now. So consists of hydro, about 6,000, more than 6,000 megawatt. So we also have geothermal. Geothermal now is about 2,175 megawatt already installed. We also have bioenergy, about 1,900 megawatt, and then we also has small capacity for wind and also solar. But energy efficiency, we are targeted to reduce emission by implementing energy efficiency. It's about 96 million ton CO2 equivalent. Try to reduce in by the flow of energy efficiency implementation. Next, please. Next. Lanjut, Mbak. Bisa pindah ke slide berikut. Related to the achievement, so far as we already implement this kind of activity program, renewable energy efficiency, and then we already account the achievement in 2020 is about 64 million ton CO2 emission reduction. And then, this is still far from our target to achieve 314, but this is a good progress in to also develop more, because we're talking about the emission reduction. So that means this kind of issue also encourage the development of renewable energy and energy efficiency. And from this target, from this achievement, so you can see here in the slide, about more than 12 million ton CO2 equivalent from energy efficiency activity, and we are also produce the emission reduction from renewable energy about 34 million ton. So this is our achievement now, and we are still try to boost our achievement, and especially in energy efficiency and renewable energy, because like you already know that in 2025 we try to achieve the target of renewable energy about 23%, but now the situation is still only 11.2%. So we need to double our capacity of renewable energy and then also activity in energy efficiency. So, but we believe that we can achieve this target by providing some additional program, additional activity, including until 2025, we try to boost the development of solar PV, because now we are on progress to develop new solar PV, floating solar PV in East Java. The capacity is about 145 megawatt, and the price so far is 5.8 cents. But we are already also identify a new price related to solar floating solar PV is about 3.8 cents US dollar per kilowatt hour, and we try to develop more than 3,000 megawatt. So this is a good sign for renewable energy in Indonesia. We are also trying to develop more for geothermal. We expect that there are additional 1,400 megawatt until 2025. So we try to be number one of implementation of geothermal in the world, because now we are still in the second large after US, and then I think when we already implement additional capacity for geothermal, Indonesia will be the largest implementing of geothermal. Next, please. Saya aja kalau gitu ya, Mbak ya, biar lancar. Yeah, more specific and related to the energy conservation, especially in the energy final, we have the target. Sorry, we have a target to achieve 17% energy saving by 2025, and then this will increase in 2030. To be 22% and in 2050 39%. In our indicator of energy efficiency also as a national level, we try to reduce energy intensity 1% per year. That means energy intensity between energy and GDP. So this indicator we use to identify how far we already implement energy efficiency in Indonesia. So the real implementation, I think, in the right side. So we can see here the cumulative energy savings so far. In 2020, we success to save about 36.8 million barrel oil equivalent. So and then but now this achievement still only 6.4% of the national. But you already know that our target is 70%. So we are still have a big challenge to achieve this target, 70% in 2025. But current situation is about 6.4%.
Sorry,
we have several sector that we try to do the energy efficiency. So industry, commercial, transportation, and household. And we are also already has some program, energy audit, by implementing energy management ISO 50001. And we are also implement a standardization, a standard for the MAPS, minimum energy performance standard for household appliances, and also try to do the same standard for equipment, industrial equipment, and also maybe in the commercial. And yeah, we are also try to change behavior in terms of energy efficiency and energy saving. So and then we are
Haris, sorry.
Yeah.
Sorry to interrupt. We have 4 minutes left.
Yeah. Okay. So I would like to try to more efficient. And then, like we already mentioned, you can see here the potential of energy efficiency in each of sector. Industry, we have, and also for the commercial, we have about 10 to 30% of potential of energy saving. This kind of number we have from energy audit activity that we already done so far. And the transportation sector also is the largest energy consumption now. We still have 15 to 35% of potential of energy efficiency in there. And then some of program we already implement now, like fuel switching, but we are still to start to develop also electric vehicle. And then for the household, yeah, we already develop, let's say, standard, like we already mentioned before. I would like to inform also that this kind of program we already implement, like standardization and labeling that we already know. Especially now we already implement for the air condition, household air condition, and now it's running well. We try to improve the energy efficiency from previously we have a very inefficient air condition that in Indonesia, but the price is very cheaper. But now we already implement this national standard, a minimum energy performance standard, and now we already has a good performance of energy efficiency. And some of others activity like implementation of energy management, implementation of energy conservation of schools, improve the awareness, and then also provide awards for the energy efficiency activity. So all of this activity we try to implement and then to achieve the target of energy efficiency. Yeah, I think I already informed this kind of achievement that we already done, air condition and also many others activity. And more specific in air condition, this is the level of efficiency, energy efficiency. And then for the more specific for air condition that we already you can see here the map. So 72% of our air condition now is still non-imported. And then 85% of our air condition still from import. So this is the situation. We try to actually improve the national capability to also produce more air condition and also other products. Yeah, I think this is additional information for our activity, but I think because we more specific in the data center now, so I think in our activity in the Directorate General of New Renewable Energy Conservation, especially in the Directorate of Energy Conservation, fully support that of all activity that has impact in energy efficiency, including in data center, because we know that data center using a very high intensity of energy, because we have to maintain the temperature, to maintain the data center running well. So I think they need more energy consumption, electricity consumption. But now I think there are new technology for this kind of data center cooling system. And then I think the next presenter will share. I think this is very good opportunity now to also to learn more about this kind of the technology. Mungkin itu saja yang bisa saya sampaikan. So I would like to apologize because now I'm not in energy conservation in daily activity, because I'm now as a director for geothermal. But again, I would like to thank you for this kind of opportunity, and we are from Ministry of Energy full support of all of activity that has impact in energy efficiency, energy conservation, to assist Indonesia to achieve the target of net zero emission and also emission reduction in 2030, and many others grid energy program that we are now in progress. So as additional information for you, that now as a part of national emission reduction and also net zero emission target, government provide some very significant program. So the first, among others, that we try to phase out our coal power plant, but step by step, like you already know that now we have about more than 60% of our capacity for the electricity from coal power plant, and then we try to phase out this coal power plant, but by using renewable energy. So in the so far we already has some program to accelerate the renewable energy, like I already mentioned before, and for the hydro, for wind, for solar, for geothermal, bioenergy, and then in the demand side, we try to also increase the energy efficiency. So that's all. Thank you very much. So Pak Faris, dan mohon maaf kalau ada hal-hal yang kurang. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Haris, for your clear explanation about Indonesia government concern on energy efficiency. And as per your second last slide, efficiency facilities in the data center also play important role for this scenario. Then, how is the industry itself see this issue? Is it already their concern also? Now, I'm welcoming Marco Ciovi as the Director of Operation at PT DCI Indonesia, one of the leading data center company in Indonesia, which is now already go public. So, Marco, please have your turn.
Hi, thank you, Faris. Welcome everybody, and good afternoon. Faris, you can see my my screen. Let me know.
Yeah, Marco.
You can see my screen.
Yes.
Okay. Well, first, welcome everybody. Thank you for organizing this important event. Thanks also Paharis from the ministry. Very important to know that the ministry is committed to energy reduction and clear energy. I will cover 3 topics today. First topic is the data center industry in Indonesia. The second topic is more about DCI, what we do, and then the third topic will be on cooling technology. First of all, just to put things into perspective, the data center industry in Indonesia, as you can see on the chart on the right-hand side, is still at the early stage. You can see it's we consume in Indonesia less than 1 watt per capita for data center, while you can see other countries such as Singapore, Luxembourg, Iceland, and Hong Kong, where the per capita consumption is 40 watt per capita. If by comparison you look at Japan, Japan is a good example because Singapore is quite unique in the sense that it's a data center hub, while Japan is a good example of what Indonesia could become. If we take the example of 10 watt per capita, it means that Indonesia could be 2,700 megawatt data center market. Okay, so it is quite significant due to the high population. Let's look at the data center market today. This is a research by Structure Research. This looks specifically at the Jakarta colocation market, which is 90%, 95% of the whole market. You can see the chart on the left-hand side from 2020 to 2025, the size of the data center. In the data center market, we measure the size by megawatt, means how much megawatt can we support. You can see 2020, 2021, 2022, contracted and built out capacity. Contracted means how much it's the real market size today. So you can see 41, 61, 83 mega, and you can also have a sense of the growth. It's a market that from 2020 to 21 almost doubled, and now is reaching you know, a more mature stage with, I would say, a growth of 20 to 30% per year. But again, if you look at this market and we compare this with the last slide of 2,500 megawatt, it's still very little compared to the potential that the market in Indonesia can be. So it's definitely a very important industry, especially for energy consumption. I will give you maybe some highlight on DCI. The company was established in 2011. We started our first module in 2012. We received the uptime tier 4 design certification. I see Patrick is also online. Uptime is one of our partners. We were the first tier 4 design data center in Indonesia. And then 2018, 2019. In 2019, we look at SOC 1 and SOC 2 certification, which are very important for cybersecurity. And 2020, we were nominated by Frost & Sullivan as the best data center in Indonesia. Overall, we have a 37 megawatt of capacity, which is around 51% market share. You can see here the progression. Definitely for us, As you can see at the bottom of this slide, our priority, operational excellence, maintenance excellence, and energy efficiency. Faris was mentioning, if energy efficiency is one of our key focus area, and the answer is absolutely yes. It's very important for us. In terms of importance of the data center sector, and also if we put in perspective the energy consumption, data center is important because support all the financial services, IT and telco infrastructure. So this is just some of the clients that we have at DCI. So some of the largest bank in US, top 3 cloud player. So if you watch video online or maybe you use e-commerce site, chance is that the traffic goes from through our data center. In terms of technical side, I want to spend maybe a few minutes on that. Definitely, if we look at JK5, JK5 is the latest data center that we built in MM 2100, 15 mega of capacity. Over there, we use a very efficient cooling system, which is basically based on water cooling with chiller, and we use air handling unit, the so-called HU, which allow us to have a very low PUE. In terms of sustainability framework, we are quite committed to sustainability. As you know, this is a topic that is relatively new in Southeast Asia. It's more prevalent in the United States. Nonetheless, we are trying to do our best to improve sustainability and support the ministry in the ambitious target for the COP21. You can see here some of the initiatives that we are doing. Definitely awareness, PUE and energy saving initiatives are of course important, and we use automation, artificial intelligence, and predictive maintenance to reduce our cooling capacity. We also do initiative in the WUE, water usage effectiveness, because as you can imagine, water usage is important. Policy and employee also important. Now, to give you a broad overview worldwide, some of those information related to DCI I cannot disclose as publicly listed company, but I can give you some reference from the world, right? If you look at the energy consumption, the largest energy buyer in the world is not an oil and gas company, is an IT company, is a Microsoft. It's the largest buyer of electricity in the world. In the world, it is estimated that ICT, which is basically information, communication, and technology, including server, etc., contribute to 10% of the worldwide energy consumption. So definitely, as an ICT player, we need to do a lot. Within the 10% of ICT, data center consume 1% of the whole energy consumption worldwide. So it's not definitely is not the biggest contributor, but is a significant contributor. That's why we have to be very committed to PUE. To give you a frame of reference on how do we do this in the data center sector or also in the ICT sector, I have here a very simple framework, which essentially says if you want to reduce energy consumption, you can do two things. First, you can reduce consumption of, you can increase the consumption of good energy. Okay, what is good energy? You can see here, gas, coal, fuel, solar, and wind at the bottom of this chart. Those are energy type. With the support from the ministry We are very active in using mostly gas in our data center, which of course has a lower CO2 footprint compared to coal. So it will be really great, I think, since I have this opportunity to speak publicly, it would be great, I think, if Indonesia and the energy ministry could help perhaps the data center sector to support for more attractive gas prices for the data center sector, because we know other industry enjoy special gas prices. So I think that could be a good approach to support the growth of this sector. I want to say that this is very strategic for us. You know, my family is Indonesian, although I'm Italian. My family is Indonesian. I've been living here for you know, the past 7 years, 8 years. So if we want to really develop this industry and we want to have, you know, a larger data center industry, same as the one we have in Singapore, we must have competitive energy prices, because that will drive the data center industry. Okay, that is the first point. So really important for us to have a very accessible gas prices to reduce the energy consumption, but also we are actively looking into solar and wind, where you can see the CO2 emission are lower. The other thing that we can do as a data center sector, you can see at the top of this slide, the total energy consumed. So in the data center sector, we are like a hotel. Okay, so the customer come and bring their own server. Okay, we provide the room with the bed and the air conditioning. If the guest of the room in the hotel have a lot of requests that we cannot change. So in other words, we cannot touch the server of the customer. It's part of the customer obligation to use efficient server. But from our side, what we can use is the PUE. So the PUE is basically the ratio between the energy that we use against the energy that the customer use. Okay, so that number, to give you some reference, in Southeast Asia is around 1.8. So it means that every watt of electricity that you use in a server, you must use 0.8 watt of electricity to cool that 1 watt of IT load. So definitely what we can do as a data center sector, we can look at mechanical and electrical PUE. Of course, the largest, well, I shouldn't say of course, but the largest driver of PUE is mechanical PUE. This is just intuitive, right? Just think about your home. The electricity losses from a server to the plug of the electricity is basically just cable. So the electricity losses in the cable is limited. But think about how much electricity we need to consume to run our AC, our air conditioning, for example. So there are fans that have to be moved, compressor that has to work, liquid that has to move from A to B. So definitely mechanical PUE is very important. So what we do in DCI, we use AI dynamic cooling. Of course, we use also chiller optimization, very efficient chiller, and very efficient airflow balancing. But mostly important, we look at PUE on a daily basis. This is an example of the system that we developed at DCI. We are quite advanced in this area. We're probably, I would say, one of the most advanced company in Asia Pacific, including Australia. We have a system that can monitor the PUE, but can also automatically adjust the fan of the AHU and the chiller unit, depending on the load of every rack. So this is a quite sophisticated compared to a normal system that is used in most data center, which is you just put the set point that you want your data hall to be. So there are a lot of losses. As you can see here, we analyze which area is more green and which area is red. So the area red, of course, is good. Red is good means there's a hot air over there. We are optimizing. Green is good where it has to be, but if there's too much green in area, as you can see in this example in the bottom right, there is green because the chiller is there, right? The cooling is there. So of course you see colder airflow. But the interesting part here is that we have developed an AI system that optimize the chiller, optimize the AHU to run a very efficient cooling. And we've been successfully reducing energy costs, energy consumption between 20 to 30% with this system. So it's a very good result. In terms of expansion plan, our DCI data center can go up to 200 mega. Currently, we have 5 modules, but we can up to 12 modules in the site. So we are developing another data center in Karawang called H2. We're also looking at city data center. In this case, we have one site in Kuningan called Edge, and another site in Bintan. So to all the students of ITB, I know ITB is one of the best university in the country. So if you are interested to work with DCI, you're welcome to apply. We have a good collaboration with ITB, and most importantly, I hope this can really support the digital infrastructure and ultimately the consumer growth in Indonesia. Okay, thank you, Faris.
Yeah, thank you, Marco, for the interesting presentation about energy efficiency concern for you as the player in data center industry. You mentioned also about the PUE and already explained it, and maybe we will talk about PUE later in the discussion. But we will move to the next speaker first. The next speaker is Michael Borisius as Business Development Manager at Asperitas. Asperitas is a clean and high-tech company from Netherlands, and we would like to know what Asperitas can offer as the solution for energy efficiency in data center, especially in Indonesia. Michael, the floor is yours.
Thank you, Faris, and thank you as well, Mr. Harris and Marco, for the great talk so far. Let me share my screen as well. And there you go. And before I start, I want to also share my appreciation for inviting me for this event. Personally, my background is based in the Netherlands, but my family background is actually from Indonesia. My mother has been born in Surabaya, and personally, I've made it my mission with the company Asperitas. I'm part of the leadership team to make sure that we have a global impact with the technology we have developed. I think this meeting is a great start, maybe to build some great connections in the region as well, to see how we can support all of the energy efficiency plans of the industry in Indonesia. Asperitas, what I will do in this talk, I believe I have 15 up to 20 minutes. I will talk a little bit about the company and the technology we have developed, and as well, especially the impact this type of technology can have on the industry, as I think that it's a great fit with the previous 2 talks already. So briefly about, maybe first myself, my background, I've been focusing on sustainability and data centers and innovation for the last 12 years or so, pretty much most of my career, I would say. And Asperitas is what we call a start scale-up, and based in Amsterdam. Our mission is really to make sure that we can support with our technology an energy neutral and perhaps as well energy negative industry globally. Most of our team, we have a cloud and data center background, sustainability, innovation, IT hardware, quite a diverse background. All of the components you will see in the technology. We see ourselves as indeed, as far as introduced, as a clean and high-tech company. Both are very important. We develop together with partners, like you see here on the screen, like NVIDIA, really high-tech solutions, but always with a mission to have sustainability impact. And we have received a lot of recognition for that as well. In 2018, Aspertos was named as by TechCrunch as the Green Tech European Startup, and the World Economic Forum also selected us as one of the breakthrough energy innovators of the last decade. Quite impressive, I think myself. We are backed by two quite strong investors. One of them is Shell, which is known as a petrochemical and oil company, but they have also a very strong strategy now on renewables and sustainability impact. So we work very closely together with them actually. So just briefly, we have started developing our technology, which is immersion cooling. I will dive into that later on a little bit. From 2014, we're on the market since 2017. And as you can see, received a lot of recognition and won a lot of awards. The most recent one is the Innovation Cooling Award from 2020 in Europe. And today we are scaling up. So we're really in the next phase of our company. At the moment, we're doubling our team. So the same as Marco, if you're interested to work in a high-tech industry, feel free to check out our careers page. We're always welcoming tech talents, but that's not the topic of today, of course. So a little bit about why we exist as a company. Again, our mission is really to have sustainable impact. And Patrick, who will speak later on, will recognize this. We look a lot at the Uptime Institute reports and annual surveys. They're very good to get an overview of what's going on in the industry. So I won't go into much detail, I'm sure Patrick will, but as you can see here, a few of the trends we monitor as a company, and we like to make sure that our technology can support the industry with those different trends, different challenges and requirements we see. As you see on the left hand, again, sustainability, I think, is key for the global data center industry, not only in Indonesia, but also in Europe and the US and many other regions, actually. And that goes beyond energy efficiency alone, which is a good first step. But just as other industry, we have to make sure that data centers can be as close to carbon neutral as possible. And that brings a lot more ownership and responsibility to also monitor carbon emissions, and also track and adopt new innovations. At the same time, we see from another report from Uptime Institute a lot of environmental challenges, and I like to mention one that's access and availability of water, which always has been a great medium for efficient cooling. Actually, in a lot of regions in the world, access to water is a challenge. Even in the Netherlands, in the summertime, this is increasingly a challenge and also being regulated. So that's another challenge we need to solve as the industry. And then on the right hand, you see more technology drivers for the data center industry. And it's great to hear that DCI, from the talk from Marco, is actually already adopting quite some of those trends. One of them is automation and intelligence. I think that's quite key to make sure we continue to develop and learn from the behavior of a data center and see where optimizations are possible. As well, we see a need to bring data centers as close to the end users as possible, and next to very large data center campuses that can be a bit more on distant, what we call edge, right? So we see that in a lot of urban areas, to support businesses locally and to develop new applications and to bring content close to the end user. Smaller data centers need to be built in an urban area, which is very challenging, especially in Southeast Asia with the climate and the humidity and the high temperatures, and as well a limited availability of space, right? So there are different kind of challenges the data center industry needs to solve globally for different kind of applications. And we strongly believe that changing the model of how data centers are designed and operated by adopting another advanced cooling technology based on liquid, this can actually a great leap forward. So if we look at those challenges again and translate it into I would say the four main categories we see and we would like to have impact on with our technology. The first one is performance, something we haven't spoke about just yet, but next to energy efficiency, there is now a great driver of new technology that needs to be adopted and facilitated in data centers. As Marco described really well, most data centers are like hotels, so guests bring their own equipment, and this equipment becomes more and more powerful. For example, to run AI applications or very advanced real-time entertainment platforms like gaming. And this is a special type of hardware that we see many more users now actually adopting compared to a few years ago. And this type of hardware is very difficult, if not actually impossible, to cool with air. It's just science. It's not possible to bring enough flow of air over the hardware to cool it efficiently. So you see already this type of hardware actually adopting liquid cooling. So if you look at the different server OEMs like Dell and as well the CPU and GPU component OEMs like NVIDIA, they increasingly use liquid cooling solutions for their more advanced hardware platforms. For us, this is the number one driver we see for our technology. Large enterprises are looking at those technology roadmaps from those OEMs, and they realize that they have to change the way they operate their data centers and use cooling actually to be able to use this kind of hardware. At the same time, I think that's great to see as well the room for expansion in Indonesia. I think that's a very early market, and therefore we see now more and more the need to develop data centers fast, but as well efficient and on lower cost. So data centers now can be quite complex to build and very high investments are required. But with more and more data centers required across the globe, a more efficient way needs to be actually adopted by the industry. At the same time, just like any other industry, it needs to be as sustainable as possible. Again, and the fourth trend, I mentioned that already, we see both hyperscale data center campuses now being developed, but as well a requirement to bring data centers in urban areas, which is a very different kind of environment. For example, in Amsterdam, where we are based, there is quite some limitation on available power. So we can't distribute high amounts of power anymore to every part of the city. And that's limiting actually the size of data centers and where they can be located in the city. So this is a real challenge in some urban areas. So what we have developed is immersion cooling, and what you see here on the screen is just a quick recap of where we see actually the benefits and the impact, and it relates to energy. So in some cases, and I will show some impact case that translates as well to probably the Indonesian environment, we can have a really strong impact on the energy footprint as well as the physical footprint. We simply need less physical space to do the same job with the hardware. And that translates as well to a great business case. We can run components on higher performance all the time, because there's no risk anymore for overheating. So what we would like to see as know today as peak moments of hardware usage and components in terms of performance, we can do that all the time with our technology, which is a great benefit for some applications. And then the last one is probably less relevant for Indonesia. At the same time, industries across the globe, they generate energy for heating, for example, for labs, breweries, hospitals. They all need hot water for different applications. It's very simple. Data centers, they use energy in the form of electricity. It's being transformed into another energy, which is thermal. And in most cases, that's hot air. With our technology, we can turn most of the energy in a quite usable energy form, which is hot water of quite high temperatures. In Europe, this is really in demand to heat houses and hotels and industries. But I could imagine, for example, in warmer climates like Indonesia, this is less in demand, but industries can still use the energy. At the end of the day, energy is valuable. It's a resource, and we should make sure that not to actually it goes to waste as it goes now in most times. We also see immersion cooling as part of a wider approach to help data centers become carbon neutral and negative. For that, we strongly work together with Shell as well, and they offer different kind of energy services like renewable power and heat reuse and carbon credits as well to offset the footprint. So part of a wider proposition to data centers, and I think Marco already shown a roadmap of different choices you can make in types of renewable power as a data center. We see immersion cooling part of this kind of support package, let's say. And if data centers take on all of those initiatives, actually they can make a great leap forward to sustainability and close to carbon neutrality. And one of the things I didn't mention, but our technology is liquid cooling, and we use water in terms of closed loop system, but we don't consume water. So we don't need access water all the time and consume it. It's not going to waste. It's not being evaporated. It's a closed loop system. So it's a very efficient as well technology in terms of water consumption, which is now increasingly more and more important next to power. So very simply put, we like to make data centers more sustainable, high performance, so make sure that they can facilitate all of the high performance hardware that's required in the next few years, and be flexible. And with flexible, I mean flexible choices for companies like DCI to wherever they want to build a data center, right, that it can be possible. If that's a limited space, if it's limited power or cooling availability or very high ambient temperatures, we strongly believe that with the next, I would say, data center a model of operation, data centers could be of the same performance and sustainability anywhere, and that's possible with immersion cooling, right? So even in Iceland and north of Sweden, where they have a lot of renewable power and a really favorable climate environment for data centers for free cooling, we can build the exact same data center in that location as in Indonesia. So that's, I think, a great change. As also mentioned, right now in Asia or Southeast Asia, POE of 1.8 compared to Europe, which is now, I would say, 1.2, 1.3 in most areas. That's a great gap between those two. We strongly believe that we should bring that closer to each other. And I will show a case actually just after this. Just a quick overview for who we do this. Actually, we do that for enterprise data centers like banks. We do that for cloud providers, telco providers. They want more and more sites, even thousands of sites to support 5G compute power locally. And then immersion cooling is a great technology because the environment around doesn't matter anymore. And we do that also for high performance computing. Just a visual for you who have never seen a technology like ours. This is an example of a data center, 10 of our systems, about 0.5 megawatt, 30 square meters. So that's super small and very simple data center design, as you can see. I think Patrick will mention as well a few other liquid cooling technologies, so I won't dive into that now. Just a quick comparison of where we are. Today, most of data centers are using a form of air cooling. You have also water cooling, which is quite efficient, but not very flexible and quite costly as well. We provide immersion cooling, which has a great benefit in terms of POE, as close as we can get to the one, which is the ideal, of course. And there's also something like two-phase immersion cooling, but the downside of that technology that it has a very high global warming potential. And as mentioned in the previous presentations, that's not something we want as an industry. So we don't see enterprises that adopting. We see, for example, cryptocurrency mining users adopting two-phase cooling. So we are in this group, immersion single-phase cooling. I'll skip this one for now as well. Looking at the time, Faris, I'm quite aware, and maybe I can catch up actually a few minutes, so we're back on schedule again.
Yeah. Actually 5 minutes left.
Okay, there we go. Yeah, should be all right. Yeah, so this is what we provide, a very unique immersion cooling technology, and quite special compared to others. We don't use any pumps to circulate the fluid. This is all done by natural convection, so there's no moving part. The climate advantage of this is that we can cool with very high ambient temperatures. Even 45 degrees Celsius ambient temperature is not a problem to cool IT hardware in our technology. So that's a great advantage in regions like Indonesia. We also have deployed this in India, where the requirement was to use free cooling with 48 degrees Celsius ambient temperatures. That's not a problem. So that's something we specialized in, I would say. So again, this is the product, how it looks like in a data center, actually a normal data center as you would see today. That's not a problem. You can apply this technology in any kind of data center you would like. This is how it looks inside. Again, for those of you who have never seen that, what you see here are servers, and instead of horizontally placed, they're placed vertically, and you can hardly see it. It's a very transparent and pure fluid, actually. It's all immersed in a fluid. Most people perceive it as water. To be clear, it's not water. It's a dielectric fluid, which is also used in other applications, for example, to cool batteries, right? It's also liquid cooled in most cases. So we do that in a pretty similar way. And again, here you can see the fluid a little bit better. Again, there are no bubbles in the system because there are no pumps. Just in this case, someone was blowing in the fluid, because otherwise you can't see the fluid. Actually, it's that transparent, just for you guys to have an idea of what it is actually. And we use a shell immersion cooling fluid specifically designed and developed for this purpose. Again, we have a very strong partnership, and it's as efficient as it can be and as safe as it can be as well, but we won't go into that in detail. Actually, what I would like to do, looking at the time for this, I would like to skip actually this part and move on to the impact we can have with this technology, right? Because that's where it becomes really interesting for the industry. This is a great example. So this is a traditional server rack comparison, actually based on an open compute solution. That's the type of solutions Microsoft and Facebook are using globally. We have a great partnership with IT Renew and developed a new solution based on that same hardware stack, but then in an immersion cooling shape actually. And you can see that even from a traditional server rack to an open compute server rack, it's quite efficient. Instead of 12 ventilators per server, they only need 2. But in an immersion version, there are no ventilators in a server anymore. So Mr. Harris was talking about power efficient servers as one of the top priorities. And this, the great thing of immersion, is always more efficient than air because there are no ventilators in the server anymore. So instead of in total more than 400 ventilators or 96 in the more efficient rack, there are 0 ventilators. So there's direct impact. No matter what you do, it's always having this impact. That means practically between, I would say, 10 and even 20% of power consumption per server, which is quite significant. That's what the ventilator requires within a server. Looking at more at the data center facility side, there's always impact there as well. And I made a comparison just for this session, actually, compared with an air-cooled 10 megawatt data center, which is, I would say, maybe below a little bit average, but it's a nice module to use, and a PoE of 1.6. And I just heard actually that's also a little bit low compared to the regional average. But you can see, even in terms of a PoE of 1.6, we have a great energy footprint reduction, almost 40%. Mostly, we don't need that much power cooling anymore, both in the server and in the facility. So instead of looking at chillers and other kinds of cooling solutions, actually for data centers, dry coolers are a great solution for immersion cooling. It's all we need. So that translates to a much lower PoE, a higher hardware performance, less space required, and a great business case, and no water consumption, as mentioned. So I think this is a great case in comparison to most data centers practically now built in the region. Immersion cooling can drastically change that if it would be adapted, right? How does this compare to the most efficient data centers out there today? And those are the data centers like from hyperscale cloud providers like Microsoft and Facebook probably. And they report a PoE of 1.09. Let's assume that's correct for this discussion, right? If we translate exactly the same to an immersion data center, and this is actually how that setup looks like, you can see that we require much less space as well. You can difficult see it actually at this moment, but we also don't need the height. So sometimes data centers have 6 meter high ceilings in their rooms. We don't need that. We just need 3 meters and that's it. And then there's some strategic benefits even for those very efficient players that you can bring data centers anywhere where you would like. Again, the environment has no impact, right? So it's a very strategic as well way of looking at data centers differently. Without negative impact on the environment as well. There's no noise, there's basically no negative impact. So even for the most energy efficient data centers globally, immersion cooling is a great way forward, as well to make sure that they can actually facilitate those next generations hardware. They still have that challenge, even if they're energy efficient. So just an example for who do we work for. This is a great public case we can share. Unfortunately, that's quite common in our industry, not to be able to share a lot of cases we work on, but this is public. It's a French but global bank, Crédit Agricole. They run tier 4 data centers in France, the only ones actually, as far as I'm concerned, Patrick, if I believe the data center on your website actually. And they have decided to scale up both of their locations actually with immersion cooling. After more than a year of piloting and testing, they estimate that they can go from a 1.4 PoE to a 1.04 in France, which is a great, of course, benefit for them, just as an example. So that's, I think, about it. First, just to finish here, actually, there's a lot more information about this technology for everyone who wants to get to know this better. And as well, we are used to work with organizations to have them experience this technology, right? So for every user so far, because it's quite a new technology, it's a new experience, right? So they do this for the first time. So we help them with their roadmap from low-level testing to advanced testing on larger scale, and helping out designing their scale out and scale up plans actually for it. Again, this is an innovation, and as an organization, you take that step by step, and we support organizations with that as well. So yeah, I would like to leave it there first, if that's all right.
Yeah, thank you, Michael, for insightful presentation about liquid immersion cooling. I myself has some questions for you, and I believe all the participants do so, but we have to hold it first because I want to welcome Patrick Chan as Vice President of South Asia Uptime Institute, as a leading certification and standardization institution in data center, to present about their role to standardize any new solution and technology in data center. And also I take your presentation about the tier 4 in France data center. Maybe Patrick can give more explanation about this one. So Patrick, you may start it.
Hello, greetings, everybody. Thank you. And I'd like to basically thank the organizer for inviting the Uptime Institute into this event. And I also look at heard the keynote from the Director General of the Ministry of Energy and Environment with interest. Thank you, Marco. Nice to meet you first time on the screen. Hi, thank you. I will respond to you on your LinkedIn shortly. And also thank you, Michael, for the information insights on the data centers, and also the support of both Marco and Michael on the Uptime Institute data centers. Now, let me basically begin. I'm basically the Vice President for South Asia. I'm based in Kuala Lumpur, Malaysia. And this is a profile of myself. I've been in this industry for a long time, 30 over years plus, both in ICT, data centers, and all the industries that basically I have basically covered in my lifetime. I'm almost the age of my career. I'm 62 this year, so to some it's only the start of my life. Anyway, I've been well-versed in data centers, resiliencies, and in terms of from the Immersion network power, both in power and cooling. Now, a bit of Uptime Institute, if those when the audience may not know who and where we are, our head office basically is in the, Seattle, in US, and they have what you see here, all the offices within the globe. All right, and in terms of certification, the Uptime Institute basically has certification all over the world. 1,900 certification plus in over 100 countries. We are almost going to reach 2,000 certifications very soon by this year. The certification, just to let you know, I'm not going to go through this very important because because the whole topic is about cooling and the importance of cooling. But for those who are interested, the whole certification that you just heard from Marco and from Michael, it begins with this whole process of design, facility, and operations. These are basically the sequence, we call it start with the end in mind. I won't basically have this talk about it, but I usually have a session that I talk about it. It's almost about 45 minutes session. We could do this on a separate note or face-to-face or on the Zoom or web link. I've also written a white paper on the value of certification in 3 languages. Not that I know those languages, but basically English, and I've got someone to translate for me in Bahasa, as well as in the Vietnamese language. So for those who actually want that white paper from me, it's free of charge. I'll be happy to share that white paper on the tier certification process. Now, the offerings that we do is on tier certification, the credit courses, and the data risk assessments. So basically, these are the things that we look at in terms of data building characteristics and facility security, which we have added into the DCRA, Data Center Risk Assessment. Okay, we talk about that another time. We offer courses that basically helps to identify cooling, identify the design, the right design to basically help to enhance cooling efficiency and sustainability. Now, let's talk about efficiency and density, which I am just going to recap what the 2 speakers, the esteemed 2 speakers have talked about. I have not actually seen the presentation, but I rather somehow figure out what they're going to talk about. And one of those are PUE. Now, the PUE basically in the Uptime Institute survey that we have done from 2017 right up to, or 2016 right up to 2020, you can see the PUE is actually coming down, right up to 1.59. It's almost flat, and it's not really going up. There are many variables of it, but most of the things is basically of awareness. So people basically require, and clients require the PUE to be at a set point, a certain set point, certain threshold. That's what it's doing right now. Okay, and basically on this, if you look at the region that we have done, in terms of Asia Pacific, the PUE is 1.69. That's the average PUE. There are, of course, room of improvements, and liquid cooling basically plays a very important role of reducing this PUE to some point of 1.03, if I recall correctly. Then we talk about density. Well, the density of per rack is not flat, it's growing. We used to talk about 5 kilowatt per rack, but now it's even going more than that. They are basically going up to even 10 kilowatt per rack. So what you see here is about 8 something. And I've seen some we're talking about even the 10, 20, 30 kilowatts per rack, and that's pretty high. That's where cooling becomes a very important discussion in today's event. Now, if you look at that, let's take a look at the density. Has the organization average power density increased in the past year, or is it shrinking? Well, basically, if you look at it, most of them actually saying, yes, it is going up, especially yes, but slowly to 53%. And then if you look at it, some of them say almost the same. Some say it's shrinking, but the majority that is basically saying is basically yes, rapidly 16% as compared to the last year, but the majority of it saying confirm that it's growing slowly. So cooling is a very important area. And why do I say that? If you look at the outages, the cost of outages, that I did a presentation a couple of months back on the outages to one client. They want to know what are the outages that actually happens. And most of them are basically power. And of course, other than the system, the software IT systems, it is cooling. Cooling is about 30%. If the cooling is not designed correctly, if the design is underestimated, it does cause an outage. All right. So on here, we basically look at the 2 areas of the carbon footprint. I think we talk about carbon footprint, that's very important. And if you look on the, basically on the left side of that carbon footprint, we basically look at the need for new technologies here. The requirement, one thing we notice here is a great news that most of these ICT and devices and data centers, the areas of this are coming down. So management actually will be under pressure to invest more, partially to protect against weather events and partly to migrate cleaner technologies such as software-defined power or direct liquid cooling. So basically, you will know that there is a reduction that's shown in this chart, in this particular paragraph, on how IT operators, IT managements, data center management are looking at to reduce it. So basically, if you look at it, the target for this is up to 2030, where they will keep the world to 1.5 degrees Celsius warming, but then they want to, but then they will show that the data centers in the carbon emissions from 2020 to 2030 are on the trajectory to fall in the 5 key areas, which are basically data centers, user devices, mobile networks, and fixed enterprise networks. So overall, the IT sectors really need to cut the carbon emission by 50% from 2020 to 2030. On the other side of this slide, you will see that basically it's led by the biggest colo, cloud and colo, basically, that are in making good progress in carbon emission and wasteful energy. Now, if you look at, probably you heard that Microsoft basically have actually come up with data centers under the sea. So these are something that they're experimenting and they're doing. But then the thing is that only Microsoft is currently doing this. I'm not sure about Google, but I know Microsoft is doing this. But then again, let's talk about terms of maintenance. How do you actually maintain this? Is it through AI, through remote, or through basically to someone diving into the sea to maintain this? There are a lot of things to learn on this, and the impact of the climate change on data centers basically is growing. We talk about extreme weather. We look at legislation scrutiny. I think the Indonesian ministry is looking to that, legislation and customer losses, and the need for new technologies. And this is very interesting, the need for new technologies. Basically, it's something that we will need to look at, in terms of where the 4 big companies, Amazon, if I recall, Amazon, and then we have Microsoft, and then you have Google. Basically, they are looking at reducing carbon emissions. They are coming up with their own standards, if I recall, their own standards. And this is something that is no longer a greenwashing. What the meaning of greenwashing is that people say, oh, yeah, I will improve my carbon emission, I will improve my PUE and all that. But these are the guys, the big guys, are going to come out with a standards in terms of carbon emissions. So just to recap, if I recall, the 4 big guys are Amazon, Digital Reality, Equinix, Facebook, Google, and Microsoft. They're actually not 4, they're more than 4. Basically, they have made very ambitious and specific commitments to achieve carbon neutrality in line with science-based targets within the next 2 decades, meaning that this is no longer greenwashing. Supply chains, including data centers, will have to come out with ways of minimize the emissions. Gone are the hungry blade servers. So they have to come up with new technologies. Moving forward, here we have these slides basically talks about high density adopting large AI and other applications are there for their transformation. We have little choice whether to use liquid cooling. So again, this is something that we actually look at it, and believe me, right now at this point in time, most data centers still practice airflow as best practices. With all racks facing front, data center engineers basically have hot hour, cold hour organization on the server racks, separating cold hours and hot hours as one of the best practices that traditionally they are doing. But all this basically will change. During the 90s and the mid-2000s, designer operators worry about the ability of air cooling to the power-hungry servers. And this is a fact where now they're looking at airflow management, focus on effectiveness, and efficiency, as well as sustainability. With new design considerations and data center architect, liquid cooling has taken a new form, making the solution far more consumable as ever. This is very true because some big data centers analytics servers are highly sensitive by particle contamination. In addition to the physical contamination, there are also threats to gaseous contamination. Certain gases can be very corrosive to electronic components. So basically, Michael, we can confirm this, and basically this is what people are looking at. In liquid cooling has introduced new levels of efficiency capabilities around the scale and optimization around server workload delivery. Of course, we need to note that what sort of liquid cooling designs are we looking at, what sort of designs and what they're for. There are a few like edge and smart cities. Basically, we're looking at oil and gas industries, and we're looking at virtual desktop integrators, infrastructures, high power computing. We also look at financial services, research and education, and especially gaming. Gaming basically are using very high density in terms of their delivery, in terms of programming to provide esports, e-gaming, and e-entertainment. Then we look at liquid cooling versus immersion cooling deployments. Then again, when we have this, probably after this presentation, there'll be the panel talking about the pros and cons, and we look at basically in terms of density and capacity, scale, efficiency, costs and the way of support and the supply chain ecosystem. The new ASHRAE basically has come out with the Fifth Ocean Guidelines recently and identify classes of water temperature in anticipation based on liquid cooling for IT equipment. So basically, this is something that ASHRAE has come up with more recently. And they basically recognize that liquid cooling has gained traction. And there's a group actually called 90.4. They're working on basically coming out with, let's see if I recognize that liquid cooling, working on accommodation, since cooling could occur within the IT equipment and the rack itself, which caused some controversy, and the standard is intended to stop at the rack. So they're going beyond that, having a discussion as we speak, coming up with guidelines for liquid cooling. So why is liquid cooling on the rise? If you look at this, taken from the Uptime Institute, basically the liquid cooling market is estimated to grow from 1.2 billion in 2019 to 3.2 billion by 2024. I've actually checked where are the main players in the liquid cooling. Was it in the US or in Asia Pacific, or is it Middle East and Africa? But I was told that basically it's very much primarily in Europe. So congratulations to the European people to be the leaders in this, and probably there'll be followers and learning from the experience and how liquid cooling actually helps in high density industry for the coming future data centers. And basically there are two reasons for this investment we look at is basically the AI accelerators. Most data centers basically have at least higher capacity of 10 kilowatt, and 20% have 30 kilowatt and higher. Basically, now we're going to look at, there are some data centers who are coming out with higher than about 60, but we have not actually heard of anything that anyone having about 70 to 100 kilowatt density so far. And then this is part of the content, and I also see one of the reasons is because of the COVID-19, post-COVID-19 or the current COVID-19 pandemic, that has created a lot of online businesses, a lot of remote learning, everything is all done online, the new norm. So this actually has created a higher density in terms of operation, IT operations. And edge deployments, business today is more connected to the machines for manufacturer, industry manufacturer, and others, bringing computing, power, and storage close to the source of generating the real-time insights for decision making. So basically, these again are the two main reasons that the Uptime Institute has actually identified. More of this information can actually be found in our insight track. Feel free to find more information. We have every time 5 trends, climate changes, COVID-19. I'll be talking about artificial intelligence in 2 weeks' time with another organization. I think it's organized by Indonesia, and also on the 2021 survey, annual survey. Will be interesting, and do please register and join. There'll be invitation sent out. So, and then last but not least, on top of this, we also need to understand the efficient IT. Liquid cooling is just one part of it, and it's only, perhaps I'm wrong, it's only applied when data centers are greenfield, new. Okay, what happens if you have old data centers that's 5 years, 6 years? How do you apply liquid cooling? How do you apply reduction of carbon footprint? Well, basically the way I look at it is that you have to look at the efficiency of IT, the way they assess their IT efficiency. How do they showcase a good stewardship of corporate environment resources and provide a good story? How do they rate against their peers across the region, amongst the vertical and the industry in terms of score-based benchmarking and the technology adoption perpetual ways? How do they basically apply that? And the Uptime actually applies, do introduce efficient IT assessment. We look at leadership, 3 structures. One of them is leadership. I look at cloud computing strategy. We look at culture and recognition, energy management program. And we also look at the IT infrastructure, where we look at the cloud computing and utilization, the IT assets lifecycle management, the rack management, and as well as the last is the data center. We look at site selection. We look at resiliency and redundancy, sustainability design features, space, power, cooling design. So these are things that it also begins inside those data centers who are running, 5 years and above, how do they basically reduce carbon emission? How they basically apply liquid cooling? I basically look at it, liquid cooling can only apply for new data centers. What about if you come in, if those with the existing one, how do you basically integrate with the existing data equipments and along with the SLAs, along with the what they call the vendor management. And also there's also a fear about liquid cooling. Then sometimes they look at it's run on mineral oil, correct me if I'm wrong, and they're looking at is the leakage hazardous? That's the fear that we can talk about it in the panel, because there is a discussion that we did on liquid cooling about, I think about 3 weeks ago. We basically had a discussion, and we from the uptime perspective, we have people calling in and ask and give their views about this, their advantages, disadvantages, their concerns. So it'll be great for this session for the panelists to be part of it, and we can share from the uptime perspective. So with that, I think mine is 15 minutes up. Please look at the website. Please look at my email. If you want a copy of this presentation, send an email to me and I will basically respond to you immediately. Okay. With that, thank you very much. Faris, over to you.
Okay. Thank you very much, Patrick. That is all for all speakers. Very fruitful speech and presentation. Okay, then here it is. We will enter the panel discussion. So the speakers may ask each other, but I still lead the flow of the conversation. So I will start with my question to Marco, maybe. All speakers were mentioning about PUE and already have explained about it. From your side, Marco, have you considered about to decrease more about the PUE from your for your data center? Actually, you have mentioned about IHU, but have you considered another solution for the cooling, especially for liquid cooling? And if yes, what is your constraint, maybe your difficulty to implement this thing to your data center? Yeah, we understand that your data center is a co-location. It's maybe it's up to the client whether what is the technology should be implemented in their data center. But it's good if we will know about your thought.
Okay, maybe Faris, I just focus on the PUE first. I think that's a more focus. Yeah. So first of all, the PUE, as you know, is the ratio of how efficient are you cooling your IT equipment, and is a number from 1 above. TPS is a positive number. When you look at the PUE in the region, as also Patrick mentioned, Southeast Asia is around 1.7, 1.8, largely because most of the data centers in Southeast Asia are built on older technology. The other thing you need to consider when you talk about PUE is where is your data center located? A data center located in Australia or in Europe with seasons can benefit from free cooling during winter, for example. While in tropical country, unfortunately, we cannot do that. So what we can do in this part of the world is look at, as a co-location, as a co-location player, we can look first of all at measuring the PUE. So you need to know what is your PUE, and you need to measure the PUE through time. Second thing, you need to have a program to reduce your PUE. No matter how good is your PUE, you always have to try to reduce. There are many actions that you can do, but as we said, most of the PUE is mechanical. In Indonesia, based on my knowledge, the new data center average PUE between, I would say, 1.3 to 1.65. Many of the data centers that use air cooling technology are closer to 1.6, 1.65. The data center they use water-based technology are closer to 1.3, 1.35, 1.38. I must say there's also, Faris, a lot of noise about how to measure the PUE because some data center provider advertise PUE of 1.2 in Indonesia, which is they only measure the cooling part of the PUE, they don't measure the whole thing. So when it comes to PUE, you need to read all the fine print. And we collaborate with the largest cooling player in the world, and we design with them a most efficient cooling. There are many tricks you can use, Faris, in design, and then many tricks you can do in operation. Okay, so in design there are two key drivers that you can use. The first one, you can talk with your client, and this is a simple thing. I think it's a big thing that we can do in the data center sector. You can talk with your client and convince the client that they can run the data center at high temperature. Okay, the IT equipment by ASHRAE standard, I think Patrick knows, is around 22 to 25. Those are typically the recommended range. Those range, are meant to make your equipment last forever. Okay, but in practice, with the current rate of technology advancement, the IT equipment gets changed every 5 years. So there is no reason to run a data center at 22 to 25 degrees. In fact, if you look at Facebook in Singapore, they are running, I think, the data hall around 30 degrees. So the big trend here will be, can we increase the existing server, just increase the temperature? I guarantee you nothing will happen. If anything, maybe your equipment lasts 1 or 2 years less. So in non-critical equipment, that's definitely one of the things that we can do. Number two, I think on colo side, we can look at our cooling efficiency and try to reduce the cooling of the cooling load. So that basically, if you are looking at a water-based system, mostly involves three things you can control. The first thing you can control is the temperature of your chiller system. First, warmer water, less energy, right? So you can try to optimize that. The second thing, you can look at the pumps on your system. And then the third things, you can look at the fans, the fan of your system, right? Last point on liquid cooling, I think is a really exciting area. Unfortunately, I think in this part of the world, yet to arrive in the co-location space, yeah. But I am sure that the cloud player and other maybe banks and financial institutions are happy to trial that. I think from our side, it's a bit harder to use because we are co-location, yeah, Faris. So it means we have to follow the rack of the customer, right? So we cannot force the customer to use a liquid cooling. But nonetheless, I think it's a very interesting technology and should be explored. Yeah.
Okay, thank you, Marco. So, Michael, do you have any comment from what Marco said before? Because for liquid cooling, it seems to be have too nice for today. But how do you think?
Yeah, I mean, as I mentioned in the last part of my presentation, for most of users and operators, liquid cooling is still relatively new. That requires an innovation approach, right? Which actually many organizations find very difficult, especially data center operators. They're used to run, I mean, optimize and run as good as they can all the time. Adapting an innovation like liquid cooling requires another approach, going from small-scale testing and piloting and working with partners that are maybe not familiar yet. And that's a different, I would say, element I see now, that the data centers now increasingly, also including co-location data centers, at least in Europe, are using to explore a technology like ours, right? So we very much realize this is another way of working. Data centers will look different than what they used to be with a technology like ours. And that requires an experience to make sure that well, it fits your standards, but as well, what will be the potential impact. That's very difficult to share on paper. So for that, really, you have to have that first owned experience. That's one. So, and indeed, Marco is right about where do we see the technology first. Indeed, we'll see this first, and we have seen that first at enterprises, at telecom providers, single tenant owned data centers. And let's not forget, there are many of them, right? So as customers or users, enterprises that will not sit in a co-location data center, they're running it somewhere, right? That might be in-house, a single tenant data center. Those data centers are usually even less efficient than co-location data centers, right? That's the great advantage of bringing your equipment to a co-location data center, is that they're extremely efficient and operated very professionally. So that is a global concern, and that's also a part of the data industry that's less well monitored. So that's where we will see it first, because that's a great way of simplifying their own data centers and getting some efficiency. However, as I said, also co-location providers in Europe are currently piloting with our technology or similar technology to get that first experience, because their customers will come to them and ask them, what do you think about this? They maybe have already run tests and they're ready to bring it to a co-location data center. And that requires also some interaction between the co-location and the user. And that's why we see co-locations actually testing the equipment for either for their own platforms, but mostly just to get the experience to work with their customers on a roadmap, instead of waiting and see when it will arrive, right? And that's something I think Patrick mentioned as well. Something that's changed recently is this is the time to explore all kinds of advanced cooling solutions and innovations that can help data centers becoming more efficient and future ready. There's practically no time to wait anymore. Both from the technology end, we see new servers coming up that require this. We see climate changes and challenges that require advanced cooling. So this is the time to look into it, to explore it, to learn from it, go and visit other data centers that maybe have adopted it, go to trade shows to see the solution providers and talk to them directly. Yeah, that's, I think, yeah, what we can do at this moment as an industry, right?
Okay. Now I have a question, more technical maybe, because I'm referring to the last presentation from Patrick mentioning about the leakage.
Mm-hmm.
Maybe first question to Michael. Could you explain again about how this immersion cooling works from Asperitas?
Yep.
Is it possible to have leakage in your equipment? And then you mentioned also in your slide that no pump use in your equipment.
Mm-hmm.
So how you reject the heat?
Yep. Yeah. Okay. Good questions. A lot of questions as well. So let's first focus on leakage, right? Let's start with the data center industry is mission critical, right? So this is the sport for all of us, and to make sure that everything that could happen in theory is not happening in reality, but you can't totally exclude it, right? So as long as you bring water or fluid within the data center, there is always a theoretic chance of leakage. Let's just face it. So you can't exclude all of the options there. So I won't make that claim. Yeah. However, what you can do, and I can only speak for ourselves, of course, you can talk with different solution providers, but one of the things we did was Looking at when we started developing, we wanted this to be validated and accepted by tier 4 data centers, again, by banks and so on. So that's very high standard, right? There's nothing beyond that. So looking at that, they have very specific requirements as well in terms of safety. And so what we did was, for example, very simple. Our tanks, let's call them tanks, they're like boxes with a lot of fluid, more than 500 liters of fluid inside. So what we did, but what you can't see actually, so it's actually the unit on my background. It has a box within a box, right? So it's very safe. It's very well insulated as well. There are leakage sensors we apply as well to see what's happening to the system. So it's also monitored, just like Marco is monitoring his data center. We do that also on a system level. So as soon as the flow changes, the fluid level, the temperatures, the system will recognize that, and just like any other building management software, but now in our case on a system level, some alarm status will be shared and so on, and it can even shut down if that's required, right? So that's the simple answer, right? And again, the technology now today is in a very different place than when we saw the earliest developers of immersion cooling many years ago already. And there's something I didn't mention, but even the 50s and the 60s, IBM and Cray Computing were already working with immersion cooling for supercomputers. All we did was taking that kind of concepts into a space and design a solution that can be adapted for cloud providers and even applied within a co-location data centers, right? But on a very high safety level. So far it has passed all of the validations. We have brought it through different kind of due diligence kind of processes. So we are very confident about the safety and the reliability of the system. You mentioned also the pumps. Indeed, any immersion cooling, if you use that, you would use a pump to transfer the fluid, the hot fluid, to another place. It's that simple, right? In our case, we don't do that. The hot components is heating up the fluid. The fluid itself moves to the higher level in the system. So we have layers of temperatures within the system. And that's great because as long as we don't mix the fluid inside, we don't maintain a low average temperature like 30 or 32 degrees Celsius. No, we have layers of different temperatures ranging from even as low as 20 degrees if that's required, up to 50 or 60 degrees Celsius. And that's what I mentioned. Because of that, we can cool with high ambient temperatures. But in other regions where heat is in demand, we can deliver heat. So that's very simple. Outside connected, we only need power and data and water. So within the system, there are heat exchangers, convection drives, as we call them. And from there, it goes to a secondary loop of cooling, which probably is the dry cooler in most of our cases.
So now for Patrick, regarding the certification to get the tier 3 or tier 4 certification for uptime, do you see any single point of failure for the system?
If you're referring to the cooling, there's a lot to learn. This is something
for the immersion cooling, yeah.
For the immersion cooling, this is something new. It's a new technology that, but the principles remain the same. In tier 3, let's just talk about tier 3 certification. The tier 3 is called the concurrent maintainable. And in this concurrent maintainable, basically, what it means is that each and every component that if you take it out for repair, maintenance, replacement, you are not supposed to have your critical IT system in operation being shut down. It's as simple as that. Okay, so you can take one immersion cooling out and for replacement, whatever, the whole IT operation have still to be running. Okay, that's about that. And in the tier 4, basically, it is about containment. We are about detection, isolation, and contain the fault. If there was a leakage, how do you detect, isolate, and contain that fault in the first place without impacting the rest of the data centers? In the last, the recent roundtable that we had with a lot of the uptime attendees, we actually had a session. If I may basically recall that we actually basically there was concerns that how do you treat the liquid when it becomes time to dispose of, or if it's leak? If it's considered hazardous material, they found the liquid of somewhat messy to deal with in the computer room. But however, the companies agree that it's coming. But the drivers of these companies see that the ability to accommodate these high densities and energy efficiency to gain efficiency, and basically to come to the energy saving side. They're slow to adopt this because the tier 3 and the tier 4 doesn't dictate whether you're going to use a liquid cooling or air cooling or chillers. We don't dictate that. But the important thing is that what we actually dictate that you follow in terms of resiliency. When there's an outage in either of this, your data center will still be running. Okay, and there are things that basically what we are looking at. That there's a lot to learn. In fact, we had this discussion in the table, and as you know, there are 3 types of liquid. Types of liquid that have immersion: single phase immersion, phase change immersion, especially engineered liquid on the motherboard, and cold plate running across the motherboard. These are new technologies, and it's something that, for example, they ask us the same question you asked: is it possible to get a tier 3 or fault tolerant or tier 4 in terms of liquid cooling? Receive the necessary redundancy. So we give them examples like rare door exchange create tier 3 challenges during maintenance and replacement while keeping the track running. There's still a lot to learn. There's a lot to learn in this new technology. Okay, but it's exciting. But it's coming. We cannot deny that. We cannot say you cannot do liquid cooling. It's coming. So when it comes, I think we did it for France tier 4. It's again something that it's good to know. It's good to learn. But I think that's the only data center that's running on liquid cooling, I think. I'm not sure about others. Okay, I hope I answered the question.
Okay, so it's promising, but still challenging to implement the immersion cooling, especially in Indonesia or even in the co-location industry, right?
Yeah, I think one of the things is also cost, if I may add. It's one of the costs, the whole supply chain. Let's say I want to introduce liquid cooling. Say, Michael will introduce liquid cooling to one data center. How is that going to impact the existing one? Let's say I want to do liquid cooling in Marco's data center. How would that impact in his design? Impact in his SLA with the other vendors who they're all integrated. Your servers and all that are all integrated in one way or another. How would that impact? So this is something that it's a whole new game. It's a whole new game. Yes, the objective is to reduce density, but do you actually need liquid cooling to reduce 30 kilowatt density? That's the question. It's like someone saying, do you need to drive a Ferrari just to go to the 2 blocks away from your office? That sort of things. You overkill. Sorry, Michael, it's not really but people look. I mean, this is where the sentiments from the recent session that we had is that some of these companies, these are all data centers management, they look at it as, having liquid cooling is great, but it's overkill. Unless the density goes up and up and up, where the crack doesn't work, the cracks and it doesn't work, it doesn't fulfill, then maybe that's the time when they will look at that. There are types of cooling where people look at load kilowatt per enclosure, size of data center, power and cabling needs, temperature and humidity in the environment, existing infrastructure and type of flow, whether it's raised or resolved. These are things that part of the design that the liquid cooling will still have to make a play. Whether is it worth, whether it's worth doing that, or I'm happy where I am right now. So that's the current situation, sentiment right now. Yeah.
Okay, so for Marco, continuing that Patrick's answer, we also has received question from the Zoom chat. Maybe it's also related to the previous topic. So, have you calculated demand projection of data center industry in Indonesia, and how was your approach?
Yeah, Faris, I believe that was shared in the presentation on the slide. I think it was the second slide that I showed. Suggests basically if you are interested in demand projection, there is a good organization It's called structure research. They are specialized into looking at data center growth. So I think their projection, they say by 2025 there will be around 350, 400 mega of data center capacity in Indonesia. So I think the growth is around 20 to 30% per year. Yeah, about that. But to be honest with you, as Patrick and Michael mentioned, the industry is dominated by cloud player. So you have heard of Amazon announcing their cloud region. I think by end of this year. You heard of Microsoft. There's some discussion. Say maybe Microsoft is coming to Indonesia as well. So the industry typically will see spike. So you will have 1 year where there is a lot of built up capacity, and then maybe 1 or 2 years, not much capacity built, and then spike again. So the cycle is typically 2 to 3 years, right? And I think back to Patrick and Michael's point, is in that cycle is the chance for us to introduce new technology, right? And yeah, I believe for liquid cooling, the demand for liquid cooling, my sense at the moment will be, from what I see in the industry, it's a technology that the customer will use currently, mostly for high density load. So for example, if you have a rack that needs to go up to 40 mega, 50 mega or something like that, that it's really hard to cool with the normal technology. You cannot cool it with normal technology, no matter how many fan you put, you cannot do it. So this application typically high computing or maybe AI or maybe unique area where you need to fit a lot of capacity in a small space. So I believe liquid cooling definitely is growing, and it will grow. But maybe it will take some time before it becomes mainstream. I think to a certain extent, data center is like oil and gas industry, very risk adverse and low innovation introduced because the operator don't like any risk, right? Because it's a mission critical. So it takes time, but I think the message, especially for this forum is, yeah, we need to be open-minded to new technology and open to new innovation, especially we can learn as much as we can on liquid cooling. So we can try to, then when the technology becomes mainstream, we are prepared.
I think if I may add on to Marco's response, I think it also needs to play where, like in Malaysia, I'm also involved in the National Infrastructure Eco Lab, where basically we have to suggest to the government to give incentives. I think there's incentives where, if you have a lower PUE, there will be incentive to basically for the data center in terms of tax breaks. And these are things, and also investors to come in and with solution providers like Michael coming in with that. And for these are for high density players. I mean, there must be a pull and push factor. If you go in and say, I'm going to open up shop and start selling liquid cooling, I do not think anyone will buy this at the moment. For example, how many let's look at Jakarta, for example. If it rains in Jakarta, I think it takes forever to reach your destination. I think that's important. I think and again, how do you encourage people to move from petrol vehicles to EVs, unless there is incentive, or cars that use biodiesel? So once there's no incentive, there's no push and factors, data centers players would not go for it. And there's always this supply chain management disruption, concerns to the impact with the IT operations, the solutions, whether the dielectric fluid needs to be replaced, or what if it's leaked suddenly, will all the servers be down? These are all the concern, the fears in the people. And even though it's been around for some time, there's still a lot to learn. There's a lot to learn about all this. And I think it's not something that, Indonesia or wherever in this part of the world, Asia would change. I had someone who told me that they want to introduce liquid cooling to one data center, but I think with all these concerns, and the cost and the people, the people who are basically, are they equipped to maintain the liquid cooling? These are things that we have to learn, but it will be there. It was coming, but by the time it's coming, there may be something else, nitrogen cooling. There might be people using nitrogen cooling for all I know. There'll be another new thing coming up. Okay, all right. Thank you.
Okay, noted, Patrick and Marco. So for this technology, for liquid cooling technology, for now maybe we will still wait for the development of the rack density, right? So maybe for now the needs is not here, but maybe for a couple of years from now, it will become mainstream. So also we need maybe more incentive to get lower PUE from government, for example, so we can fasten the development of the liquid cooling, and also in the spirit to have energy efficiency. Okay, actually we have another question. Maybe it is not maybe a little bit out of immersion cooling topic. We have the question, maybe for all of you, you can ask anyone. Is there any technology that recycle the heat that produced by data center to become another energy maybe? Anyone can or want to answer this question?
Yeah, good question, of course. And that's where again liquid cooling can play a role, right? So what liquid cooling can do is bring higher temperature heat outside of the data center, right? Maybe as now, maybe the standard is 27 degrees cooling, right, from a data center. That will be the temperature that they will bring out of the data center. That's quite low temperature heat, right? So immersion cooling can bring that even up to 55 degrees Celsius in some cases. So that's a big difference for a lot of new innovations that are also being developed. The most easiest way, of course, is using heat pumps to get even higher temperatures out for industrial applications. But we also, since we have started, we have seen quite some startups and scale-ups, and now as well more mature companies really looking into more innovative solutions regarding what you can do potentially with that heat. And again, we are quite supporters of that. We love to work with companies that have innovative ideas about what to do with the heat. It's not something we all see, right? You're not standing outside of a data center and see the heat actually being dissipated. But at the end of the day, it's a waste stream, that can be utilized if managed well. But in a realistic way, currently today, based on air cooling, that's very difficult. The temperatures are too low to do something, in most cases, something valuable with, let alone on scale, right? So in Amsterdam, this was actually already a topic maybe 10 years ago, one of the focus areas, and we have seen a lot of pilot projects, but not on scale. For scale, you really need system change, because otherwise it's just a one-time case, and that's not, when I look at sustainability and innovation around clean tech, one of the mistakes that has been made in the past around this kind of innovations in general is that, it will work in a pilot, right? And that's great. Many things will work in a pilot. But for sustainability, especially on a global level, we need something that work on scale. And that requires a lot more than technology innovation. That in most cases actually requires system change. We already mentioned incentives. But yeah, in general, I think, and again, I think there are great universities out there, like in Bandung. I'm sure there are great innovations and innovators looking at what they can do with the heat from data centers. Would be great.
If I may add on, the Uptime Institute actually introduced this thing called the Efficient IT Assessment. We actually have a document in our website that looks at legacy servers that generate heat. They're hungry. I mean, you have, servers that if you were an IT manager, you came on board the data center, you just inherit those old data center servers that you do not know what they were for. And they're hungry, sucking servers and energies, and it create your energy costs, and it create all your expenses, your license and maintenance and all that. So I think that one of the things to look at, is to address those areas. There was one company in the United States, that actually saved $6 million per year by looking at the old legacy servers and able to cut them off and migrate into new servers. That's what the efficiency IT assessment is about. So that's one area to look at. Yeah.
Yeah, I think Faiz, maybe on our side as a colocation player, I think one has to look at the temperature. The temperature. I mean, you guys are all engineers, so my belief is like this: extremely cold temperature is very valuable because you can cool things. Extremely hot temperature is also very valuable because you can heat things. But unfortunately, the energy in between has not much value, right? So when you look at the heat generated by server, you're talking about 30 to 40, 45 degree. It is in Europe you can heat houses for that. But unfortunately, in Indonesia, the temperature is very close to our ambient temperature. So ambient temperature, as you know, Faris, it's available for everybody, so has not much value. I believe if one want to look at this area, a very interesting branch that is now quite hot topic in data center is so-called absorption chiller. So the idea is like you run your data center with gas generator. The gas generator produce 300, 400 degree of heat because you're burning the gas. And then you put that gas into an absorption chiller. The chiller absorb the heat and translate that into heat into cooling. I think that is a really interesting technology that I believe can bring our PUE from maybe 1.35 to 1.3, 1.25 to 1.3, realistically speaking. Unfortunately, not yet mainstream in data center, but I think it's probably the closest mainstream innovation is quite close to become mainstream. So if our friends from the ministry help us on the gas prices, I think that could be a very cool technology for the data center.
Correct, Marco, correct. You see, if you're using the gas, I think you're referring to cogen. If you're using the gas, some people look at it, the gas comparison of the cost per kilowatt and versus the fuel, they're almost the same. If not even something, the fuel even cheaper than the gas. So there's no much of incentive to bring for the gas price to come down. If they come down, probably the game change. That's a game changer. Even in Malaysia, people are looking at gas as an utility, a source of utility, but there's not much difference. So this is again, it's very much from the ministry, the government, the regulators, to bring incentive, to bring it down if they really are seriously about greenwashing.
Mm-hmm.
Okay.
Talking about that, maybe the last comment, because we spoke a lot about PUE, right? And Marco mentioned that's not a great metric for many reasons. It's helpful in some cases, but I would say if we look at sustainability as a whole, PUE alone is not a great metric. To give an example, if we take out a fence from a server and we don't change anything about a data center, your PUE will go up. At the same time, you actually have saved energy, right? So that's not a great metric for it. It's very simplified, of course, but just to make sure, we mentioned as well water usage, so WUE, but there's also heat reuse, ERE. But there are many other ways. Carbon footprint, I would say reporting is going to be key for this industry, as is looking at the whole energy footprint, right? So altogether, we need a lot more transparency, and I think that's actually covered as well by the Uptime Institute as one of the areas. No greenwashing, so a lot of accountability. But that also means that in terms of incentives, please learn from Europe. Don't only focus on POE and regulate that. We have made that mistake, for example, in Amsterdam. It was a great start, right, when the performance was really bad. But to get where we need to be now, and again, to really close to carbon neutral industries, just like any other industry, POE alone is not a great metric, right?
Correct. I agree with Michael. In fact, I have a document that says POE is not the only metrics to look at data center efficiency. It was released by DCI Dynamics. Yeah. Okay.
Okay. So we will back again to the immersion cooling topic, but it will be the last. So maybe you can state your closing remark, but I'd like to ask Michael, because in previous answer, Patrick mentioning about the cost and the risk and the challenge to implement the immersion cooling in data center. So as your closing remark, what is your comment?
Yeah, sure. Yeah, actually, then too, also mineral oil was mentioned. All professional solution providers today, we don't use mineral oil. It's not a great fluid. So we all use synthetic fluids, which is you can design for this purpose, right, and qualify for it. That's one. So on the cost, it's actually cheaper in many cases. Of course, in greenfield data centers, the impact is much larger because you can design a data center around a technology, but also several technologies. So we're actually a great supporter of looking at hybrid liquid cooled data centers, not at one solution like ours, but designs that can facilitate multiple solutions. I think that will be a reality, right? Yeah, in terms of cost, I mean, there are benefits straight away. So both on the capital investment required and the operational cost as well. And to be really clear, we have seen the first deployments mostly in already existing data center sites. It's very simple, and that was one of your questions, I think, Patrick, earlier on. If you bring an immersion system, like in the picture on my background, which is a meet-me room in a data center, there's no impact to the air-cooled racks. Compared to, I would say, if you bring a high-density air-cooled rack in a white space with low-density air-cooled racks, it will have direct impact, right, on your design and how you operate it. With immersion cooling, that's just not relevant, basically. So it's easy to adapt in an existing data center. However, the impact will be lower, of course, because you have made the investments, you have a cooling infrastructure, but it's easy to do, and there's no negative to it, I would say. So that's a great way of getting the first experience as well. So I just want to mention that.
Okay, thank you, Michael. So maybe Patrick.
Okay, in my closing remarks, on my closing remarks, basically, based on Moore's law, where power density doubles every 2 years, and I see and predict that liquid cooling will be the way that data centers are going to be built and planned in the future. New data centers, I mean, not existing ones. And though it saves space, but it can also be expensive and cost. But of course, Michael chooses to debate this. That's great. But then define costs. Some people will do the mathematics and they will know how to define costs. But anything that's new, I think that the setup costs may be higher than the economies of scale, but it's more efficient and sustainable than the current way of data centers are built. Don't get me wrong. However, this is again feedback that people are looking to replace what they are working for them right now, and the use of immersion cooling require educating people. That's a fact, and what it can offer and how to operate it when you're sinking millions of dollars. And of course, the immersion perception is that it's basically a server inside submerged in the bathtub. That's what they always say. Is no pun intended. But I think it's not the end of the world, because I think by the time, to me, this is my own crystal ball that I'm looking at. And by the time that people attempt to come to a point that they want to adopt liquid cooling, I think there will be a thing called gaseous cooling, and nitrogen will be one of these coming up as nitrogen cooling. It will be happen soon. Okay, I may be out of 10 years ahead of time, but I think that's coming. All right, thanks. Thank you.
Thank you, Patrick. So maybe Marco, your closing remark, please.
No, I think a great session on my side. Maybe just looking at the big picture, basically, we've been, you know, as a society evolved, we've been taking stuff out of the ground, yeah, coal and other oil, and we've been burning it above the ground, right? And that basically has increased the temperature. That is the whole point of climate change. What people don't realize is 1 degree change in temperature is massive. It's like the difference between tornado every day and where we are now. So like it or not, we cannot continue like this. I think on our side, everybody has to do their job. So, you know, I would encourage to all the students of ITB as well as partner, you know, let's keep it simple, and we focus on 2 things, maybe immediate things. I think we can work on sustainable energy, right? So with the help of the ministry, increasing gas, increasing solar, and as Michael and Patrick both pointed, we need incentive, we need the systemic effort, otherwise we cannot do it alone. And then all the folks of ITB, we need your brain for new technology to reduce cooling and PUE. So looking forward for all the innovation coming from this university. Thank you, guys.
Okay, thank you very much, everyone, for your closing remark. So I think we have fulfilled our discussion today about energy efficiency in data center. In particular, we talk about the immersion cooling technology. So yeah, the technology itself, maybe for now it's still developing, but in the near future, maybe we can have this technology become mainstream, right? Okay. Again, thank you everyone for joining this webinar. We hope we can collaborate again in the future in the different framework maybe. And thank you also for all participants that have been joining this webinar. Hope to see you all in the next webinar of INTPF, and stay safe, stay healthy, and stay tuned for more topics related to sustainable energy from INTPF. So goodbye, everyone.